Groundwater Relief provides hydrogeological expertise and technical advice to the humanitarian and development sectors, and we do this through a global membership of over 400 groundwater experts. This video on well design and completion has been developed as a reference for people working in these sectors on water supply projects. Well design should be determined by the drilling supervisor based on the ground conditions encountered during the drilling process and not on any predefined piece of paper in a contract document. Well construction should be only undertaken with a supervisor present. Once boreholes are completed, it's impossible to assess the quality of construction as it's all underground. Groundwater Relief is delighted to introduce Professor Richard Carter, a hydrogeologist who's been working, researching and teaching on rural water supply for over 40 years. Richard will be taking us through the basics of well design and well construction, with a focus on constructing wells in unconsolidated sediments.
Once a borehole has been drilled, the well must be cased and screened to prevent collapse. The casing accommodates the pump and its rising main, which conveys water to the surface. The well screen is designed to permit the flow of water into the well without any solids. Well screens can be made from PVC, which often has saw-cut slots. PVC well screens of this type tend to have quite a small open area in terms of the percentage of the surface. An alternative is to use what's referred to as a stainless steel wire-wound screen, in which there are vertical stainless steel rods and a single wire which is wound around those rods in a spiral, and it's welded on at every point where it meets the rods. And these screens have a much higher open area percentage than the saw-cut slots that you've already seen. So in those cases where we need a large percentage open area, perhaps where the aquifer is relatively thin and relatively fine-grained, then we might well need to use this type of material. Steel is normally only required in very deep boreholes where its greater strength is needed. An alternative which is sometimes used is a screen which has larger slots, but then is wrapped with a geotextile fabric in order to prevent the passage of fine particles from the aquifer. The permeable backfill that goes around the well screen may consist of a sand or a gravel which is matched to the size of the slots that have been predetermined in the design of the borehole. And the purpose of this material is to fill that annular space and perhaps to prevent the passage of fine particles from the aquifer into the well. When it comes to the sanitary seal at the top of the well, we can use either bentonite or cement or a mixture of the two. And in our case, we're using coated bentonite pellets. The coating prevents them from swelling too quickly before they've reached the predetermined position in the borehole. Then over time, they'll swell up to many times their own volume and form an effective sanitary seal, preventing contaminated water that might be coming in from the surface getting into the borehole or into the aquifer. Well lining materials and materials for filling the annular space need to be assembled. The sump, the casings and the screens need to be measured and placed in the correct order. The permeable backfill and the sanitary seal materials need to be checked. Quantities of backfill materials need to be estimated, recognizing that some collapse of the hole may occur, which reduces the annular volume, or that the whole volume may be larger than expected. The position of the well screen needs to be determined to match the findings from drilling. Some pieces of casing and screen can be assembled prior to carrying to the rig, depending on the mast height. The casing and screen column should be lowered into the hole as soon as possible after removing the drill string. The tagline, or the plumb line, is your eyes down the hole. It's a highly valuable tool for the drilling supervisor. Groundwater Relief designs their own plumb lines based on weights of 700 to 1,000 grams using Kevlar rope and reels. Before installation of the casing, the borehole depth should be measured. Sections of the part-assembled casing and screen string are carried carefully to the rig and clamped prior to lowering. The lowest partial assembly is inserted carefully, and then other partial assemblies follow. When the total depth is reached, we measure the casing to check that it's reached the bottom. Casing shouldn't be forced down the hole. If the casing isn't installed to the correct depth, it may need to be removed and the borehole reamed. The permeable backfill can be poured directly into the annulus or through a pipe known as a tremie. It's important to record the volumes of material being installed compared to the estimated volumes, and there need to be regular checks on the depths that the annular backfill materials are reaching. Borehole development, that is the process of cleaning up the borehole after construction, is often carried out after the installation of the gravel pack. The sanitary seal material, in our case coated bentonite pellets, are poured into the upper part of the annulus. Boreholes need to be capped to ensure that they're not vandalized prior to well development or test pumping or the installation of the final pump. Finally, a concrete headworks will be constructed to complete the borehole.